Okay, so the next step in this building this ADT, right, abstract data type, is of course we're missing the remove part, right? We're missing the remove part, and that is also very simple to do. Okay, what we're going to do? So removing is the tricky thing about removing is this. Let me open my OneNote, and hopefully my screen will work today, right? And I'm going to OneNote, right? I'm going to draw this diagram to make sure that we are following how the delete would happen. So let's just say, right, you have, of course, you always have a head node. I mean, draw right here, draw, right? You have the head node, okay? Head node, and then you have a student 1, a student 2, and then you have student 3, right? This is pointing right here, that is pointing right here, that is pointing right there, right? So in order for us to remove, any of this element, we have to find two things, right? We have to find two things. First, we have to find the element. So let's just say we're removing S1, right? If we're removing S1 is very easy because you know where S1 is. S1 is the very first element in this linked list. So basically, we will go from the head, right? We'll go from the head right here, and then check if S1, right, head dot start pointer is equal to S1. If that is equal to S1, then we just remove S1 from there right away and point this, right? Point this, whatever this pointing to, point this to wherever S1 is pointing to, right? So that will take care of that piece. Okay. However, if you are looking for, let's say if you're looking for S2, right? If you're looking for S2, what will happen is that's a little tricky. And the reason is this, because it's not like adding, when you're adding or deleting, right? When you're adding an item, you just need to figure out where to add, right? Deleting is tricky because, you know, I will start by searching, is this S2? No, I'm going to go here. Is this S2? Once I find this S2, right, I need to keep a track of what's behind me, because what I need to do is that I need to take that pointer, the one in S1, and point it to wherever S2 is pointing to. So the tricky thing here is that you keep searching, moving forward, right? But once you find it, you always got to track what's behind you. You always need to track what node is behind you, right? Previous node. All right, so moving forward with that, what we got to do, go here, I'm going to say, have a function called define or method, remove node, all right? And then here, of course, you will take a self and also node to remove, remove, right? That, give me some space. All right, first things first you want to do is that you simply want to have a, like a pointer, right? Like a pointer. So what I'm going to call this, I'm going to call that a current, right? I'm going to call this current pointer, current node that I'm pointing to, right? So I'm going to get that. I'm going to say self dot start PTR, right? So now the current has the very first element so far. So now I'm going to check. I want to check if the current is if current is the node to remove, right? If that is the node to remove, right? And then the way we're going to do that is basically if sometimes I like putting parentheses in here, sometimes I don't. I mean, actually I like putting the parentheses, but Python sometimes doesn't require. So it's a I wish, you know, I like putting those there. So if current is not, of course you check if it is not null, right? And then you're going to compare if current is equals to node to remove. Now, in some cases, you know, instead of current, you can do a current.firstName is equal to node.remove.firstName. You want to check those two, right? If that's the case, if they're equal, then I'm going to say self dot start PTR, right? If that's the current node, that's going to point to current dot, what is called next pointer, next node. Oh, come on, next PTR. Too many different names I got going on here, right? And basically that will set it. And then what I'm going to do, I'm going to say current is equals to none. That gets rid of, that deletes run. That deletes the very first S1 that I got, and then you return out of it and you're done, right? If that's not the case, what you need to do, you need to go ahead and do a while loop where you'll figure out, right? You'll figure out which node to delete, right? So I'm going to say while current is not none, right? Well, that is not none. I'm going to check if current is equals to node to remove, right? If that is equal to node to remove, then I'm going to break from here. I don't want to do anything with the while loop at all, right? If not, what I'm going to do, I will create a new variable here, previous. All right, previous is equals to current, right? So that now will track this will track, this will kind of track previous node, right? Track the previous node, and then simply what you need to do here, you go ahead and set the current is equals to current dot next PTR, right? So that will basically, the whole idea of this loop is to find, right? Is to find the node to be deleted. Also we want to find. Also want to keep a track of the previous node, right? Those are very important, right? Previous node. So once I've done that, okay, once I found it, I'm not changing anything yet. I'm not deleting anything yet. I'm just still looking, right? And then I want to check here, right? Basically, I want to check here. Check each, check if found, and then here basically say if current equals nothing, then I'm going to return, right? That means it doesn't exist, right? If not, actually, this is, be careful here. You got to make sure that you have the tab, right? The proper tab. Right, now it's good because that line of statement, right? It's not part of the while loop. It's outside of the while loop. Right, that's done. Now, what you need to do now is you basically have to say previous dot next pointer is equals to current dot next pointer, right? And simple, you say current is equals to none. So I think that should do it. I'm just going to run this and see if it's node to remove. Let's go down here, and I'm adding. I'm going to put a add node dot node to remove, and let's just try to remove student 3, right? Student 3. So that would be. And before I remove that, what I want to do, I want to go ahead and print the list just to make sure that I'm removing. Print the list, and here I'm going to say print. Just like a separation that tells me that actually what I can do, instead of doing that, I can put this code in my print. What's my traverse code? Oh, it's right here, traverse code, right? Anyways, so that should be good. Running this and see if it's going to remove road number. I'm removing student number 3. Student number 3 is Rob, right? So you see here, I have Henry and I have Rob as, whatever sequence Rob is in doesn't matter, but Rob is gone from this, right? So next one I want to remove, let's just try see Henry, if we can remove Henry. That is student number 4. So right here, I'm going to put number 4, save this, and I'm going to run this as well, right? And that removes, who am I removing? Number 4 is Henry, right? Henry is gone from this list. So you can see how the remove is working as well. Now going over this again, right? Basically in the remove node method, you get that basically, that means the very first element, very first node, right? Very first node, I'm checking, is this empty? It's not. I'm checking if it's equal to what I'm looking for. If it is, then I'm going to set my head pointer to the node that the very first node is pointing to, right? I'm just switching the direction, right? And that will set that for me, right? If not, I'm going to check. I have a while loop that will continue tracking the previous node, right? So what's the reason I don't need to track the previous node in the very first element? Because I already know what is. The previous node is self. I mean, not self, is the head, right? In this case, it's the self. The head is the previous node. If it's not the first node, any other node, I don't have the head anymore, right? I have to track it. In my while loop, I have to track what was the previous one, right? Once I go through this while loop, now I know what my previous node is. Now I know what my current node to delete. Basically, I take the previous node's pointer and set it to the pointer of the current node, right? Basically bypasses the current node. So, and that sets it up. So very simple, straightforward. Hopefully this helps. Anyways, good luck.